Okay. So let's do the warm-up problem. It says, which scenario shows the block with the most net force? You look through all of those and you'll see that, well, if you've got a box, what's going on? If you've got a box, try it again. You get a box, and the two forces are opposing each other. The most net force, so the sum of all the forces, should look like this. Okay, the sum of all the forces, the one that's the greatest, will be the one that has the biggest difference between the two numbers. So, if you've got an 11 Newton force on this side and a 71 Newton force, overall that's a 60 Newton force going this direction. That's number A. For B, it's just a 2 Newton force going this way. For C, it's a 74 Newton force. So this is A, that's B. For C, it's a 74 Newton force going that way. And for D, it's definitely not a 74 Newton force, so it's C is the right answer. 74 Newtons force going to the right. That's the correct answer for C. So 2. Let's look at 2. Two horizontal forces, 315 newtons and 145 newtons are applied to a 55 kilogram sled resting on a frictionless skating rink. Well, we say frictionless, but it really is, there's a little friction there. We just idealize it. Just forget that it's there because it complicates the problem. If they are applied in the same direction, draw a free body diagram and then show your calculations. What is the net horizontal force on the sled? So let's draw a sled, shall we? Yeah. So here's a sled. That's a sled. And there's a box on the sled. There is a box on the sled. And it's on ice. So let's draw ice. Sort of. There. Oh, that's pretty good. All right. Now we've got forces. We've got forces. What are the forces that are always acting on any object on Earth? I'm glad you said it. Fg. Force due to gravity. It's always there. And opposing Fg, if it's on a surface, it's in contact. Well, we've got our normal force, Fn. So those two are always opposing each other. They equal each other. They cancel each other out. So we don't have to worry about them for this problem. But we have two forces going the same direction. We have 315 and 145 newtons. They're applied to this 55 kilogram sled. Well, let's draw out the forces for those. We've got, that should be straight. That's 315 newtons. 315 newtons. And we've got another one that's going, it's going in the same direction like this. And that one's only 145 newtons. Right. So the question is, what is the net horizontal force on the sled? Well, the net horizontal goes right and left like this. So it's going to be these two vectors added together. So you take 145 plus 315 and you get 460 newtons. For our sig figs, there are 3 sig figs here. So what would this be? We'd have to say this is, you could say 460 decimal newtons. That would work. Or you could say 4.60 times 10 to the 2 newtons. These all equal each other. But only these two have the correct number of sig figs. Okay. Next question. That was A. That was 2A. Now 2B. What is the acceleration of the sled? To figure this out, you need F equals ma. Praise Newton. F equals ma. Praise Newton. Okay. So our overall force in the x direction is this. Overall force in the x direction is 460 newtons. We don't have to, you could put that right there for our sig fig. That's our force in the x direction. We want to know what the acceleration is of the sled. What's our mass of the sled? 55, I think. Yeah, 55 kilograms. So we don't need to change that to grams or kilograms. It's kilograms, it's what the units we want. Everything's great. So now we solve for acceleration here. So we rearrange this equation. So F equals ma. I'll write it out again. We want to solve for acceleration. So we divide both sides by m. So you get F over m equals A. So you take, now you finally plug these numbers in, and you should be doing it this way, rearranging your equation first. Believe me, it will help you. It'll save you so much time in the future if you do it this way, and you'll get so many more questions correct. So it's going to be 460 newtons over 55 kilograms. This will give you a grand total with 2 sig figs here. We're limited by these 2 sig figs. It'll be 8.4 meters per second squared. That's your acceleration. Congratulations. You now know Newton's second law. Praise Newton.